Hello, welcome to Math Breakthrough series. In this series, we'll be working with 411 SAT algebra and geometry questions. Our focus for this very lesson is 7 things you need to note about algebraic expression. So let's go ahead and talk about that 7 things and solve some questions. This is why it is essential you stay to the end of this lesson. The first are variables. So assuming we'll have an algebraic expression such as 3y plus 6 equal to 12. I want to take note of some things in this very algebraic expression. Now this y is our variable, and then this is the coefficient, the constant to the variable, and then we have all these other values as our constant. So this is just like a sketch. We'll talk about this more in detail. So let's go through the notes. A variable is a letter or symbol, so it's usually a letter or symbol. That's why sometimes you call them unknown as well, that represent a value. So for instance, assuming we have y plus 3 is equal to 5. It's simply saying, what do you need to add to 3 to give you 5? And you know that is 2. So if I should add 2 to 3, I will have 5. But in this situation, they use the variable, which is also a value, you understand? But that value is not clear, so that is what sometimes we call it unknown. So what they simply did now is that they use this variable to represent the value. I don't know if that's making sense to you. So let's continue. An algebraic expression is one or more terms that contain a variable. For instance, okay, you have 3a. 3a is an algebraic expression, and the a is the variable. Y plus 1 is also an algebraic expression, so it must not be equal to something that is equation, because whenever you introduce an equality, it turns to an equation. But here it's just an expression we're dealing with for the meantime. So y plus 1, this is our variable y. X squared plus 4x plus 4, so this is the x and the 4x. Okay, so I want you to also take note of the number of terms in an expression. So let's say for this expression here and for this here, we'll have y plus 1. This is the first term, this is the second term. So we'll have 2 terms in this very expression. While for the expression such as x squared plus 4x plus 4, we'll have term 1, the second term, and the third term. So we'll have 3 terms. I want you to also take note of that. So let's go to the next part. So the next thing you want to note in algebraic expression are parts of a term. So we have the coefficient. Now the coefficient of a term is usually constant in front of the variable. The base of a term consists of the variable or variables that follow the coefficient of a term. So let me just explain this for you. So assuming we'll have something like 5k. This, is a variable. So let's say 5k plus 6. These are just 2 terms, you understand? So in these 2 terms, this k is the variable, this is our constant. Now this value that is alongside the variable is called a coefficient. That is what a coefficient is. So this term that is alongside the variable is a coefficient. This k is a variable, while this is our constant in this expression. Okay, so you just need to know that the coefficient is that value that is written alongside the variable. Now the base of a term consists of the variable or variables that follow the coefficient of the term, including the exponent. So this is the base, and now this base is just raised to power 1. But let me work with the example we have here. So they said the coefficient of the term 4a cubed is 4. 4 is the constant written alongside with this variable a, and the base of the term is a cubed. So the base is your variable, and if it has a coefficient, that's it. The next thing you want to also note is like and unlike terms. So let's go ahead and talk about like and unlike terms. So for like and unlike terms, it talks about terms that are related and terms that are not related. Okay, before we continue, I want to also talk about this. When you have value like this, x, this is just same as when we say 1x. So there is no need for you to say 1s. It's just x, because the number of x here is 1. So terms like x, 3x, this x is 1x, 3x and 8x, they are like terms, in the sense that I can say 1x plus 3x to give me 4x. They are related because they are of the same family. But if I have 2y plus 3x, they can never add, because this is y, this is x, so they are unlike terms. So the terms this x, 3x and 8x are like terms because these terms all have the same base. The terms 3x and 3s squared are unlike terms because the variables in the terms have different exponents. So you can see that here, because the exponents are different, that is the power. This one has 3x and this other one have 3x squared. so they are not the same, because this x is squared and this x is not, does not have any power, just 1. While if we have something like 3x squared and 3x cubed, they are not also the same base, so they are unlike terms. So for a value to be like terms, there has to be exactly the same. And when we start solving question on this, you are going to see what I'm talking about. So just stay tuned until we get to solve the question. But for now, let's keep going through the things we need to note first. So another thing we need to note is combining like terms. How to combine like terms. You can actually, when you have like terms, you can actually combine them. So you can combine them either by adding, subtracting, or multiplying and dividing. So to add like terms, first of all, you add the coefficients, and we've talked about coefficients of the terms. So you can see that 3x plus 4x are exactly the same. So what you simply do is you say 3 plus 4 gives you 7. Then you can just bring your x. That's 7x, because 3 plus 4 obviously is 7. And you do same also to subtract them. So like here you have 9a squared minus 6a squared gives you 3. So that's just it. Now to multiply, same thing happens. So multiply the coefficients. So it's very, very necessary you take note of the coefficients. So once we multiply the coefficients, the next thing is that we add the exponent. We don't multiply the exponent again according to the laws of indices. So here we just have 3 times 2 is 6, then 4 plus 4 is 8. We will not say 4 times 4 is 16. That's against the law of exponents or the law of indices. Same thing happens for division. We divide the exponent. So 15 divided by 5 is 3. Then what you simply do, you subtract the powers or the exponents of the variable. So 3 minus 1 here, because this is raised to power 1, gives you 2. The next thing you want to talk about is, or note, is combining unlike terms. Now unlike terms cannot be added. Yes, we cannot add or subtract unlike terms. I want you to note that. So we cannot add or subtract unlike terms. So look at this. Y plus 2 are different terms. They can never add. 3a plus 3a squared, different terms. They can never add or subtract. So we can never add or subtract unlike terms. But however, we can multiply or divide unlike terms. So we have to multiply the coefficients and also have to divide the coefficients. So let's have some questions. What is the product of this and this? So the simple thing you do here is that you have to multiply the coefficients. Multiply them. 6 times 3 is 18. Then you add the powers of the base. So a, then 2 plus 4 is 6. So 18 is 6. We are going to talk about this in detail when we start solving question, but I just want to know now what is the product of this. So same thing, multiply the coefficient. 4 times 5 is 20, and then x squared plus 1x, so that becomes x raised to power 3. So we just have to keep y, because this part of the equation does not have y, so that's just it. And same applies for division. So for division here, 25 divided by 5 is giving you 5. Then a raised to power 3 minus 2 is just a raised to power 1. Then b raised to power 5 minus 2 becomes 5 minus 2 is 3. So we are going to be having 5a, then b raised to power 3. And that's our answer for this very one. So let's go ahead and talk about the next two. So evaluating expressions using substitution. So you're going to also have to evaluate expressions using substitution in this algebraic expression. So this is another thing you want to note. So what is the value of 7x plus 1 when x equal to 1? So you have 7x plus 1 when x is 1. So all you just have to do is substitute. Since they say x is 5 plus 1, 7 times 5 is 35, plus evaluate one variable in terms of the order. So to evaluate one variable in terms of another is more like making the variable a subject of formula, and we are going to dwell on this right here. So let's say, for instance, we have y is equal to 3x plus 3, and you are being asked to solve for x. All you have to do is to isolate x or make x stand alone. So to isolate x, you have to subtract 3 from both sides, or you simply collect like terms by moving 3 to the left hand side. So this is the, in this equation now, this is the left hand side. I want to just use left hand side, and this is the right hand side. So moving 3 over here to the left hand side, you have y minus 3 equal to 3x, right? So from here we can divide both sides by 3. So you can have y minus 3 over 3 is equal to just x. I know this might be confusing, but we're going to solve questions right now, and you're going to see what I'm talking about in detail. So don't be troubled if you don't understand the whole thing. Let's go ahead and solve questions. Okay, for the very first question, it says 9a plus 12a squared minus 5. In this algebraic expression, 9a and 5a are like terms, and they're not the same with this. So here, let me write it out. 9a plus 12a squared minus 5a. So I want to subtract the like terms. They can actually subtract. So 9a minus 5a can work to give us 4a plus 12a squared. Yes. So having said that, let's look at our options and see if we have anyone right here. So you can see that our option matches with option D. They just rewrote and say 12a squared plus 4a. If you can see, our 4a is positive here, and also our 12a squared is also positive. So they just had to interchange it, which doesn't change anything. This is very, very correct. Okay, so let's solve for this one. We are going to multiply. So because they are like terms, we can multiply them. So 3a times 4a, 3 times 4 is 12. Then we'll add the powers of the variable. So 12a squared all over, they can still multiply for the denominator. So 6 times 6 is 36, and then you have your a squared. So exactly they are the same terms right now. They can divide. A squared can cancel a squared because they are the same. Then 12 here is 1 and 12 here is 3. So we are having 1 over 3 finally. So the right option is option A. So let's talk about the next one, which is number 3. Okay, let's distribute. Let me write it out and distribute. In bracket 5a plus 7b bracket b all over b plus 2b. So I will distribute. For me to distribute, I have to multiply these terms. Expanding this bracket becomes 5. I'm multiplying now 5ab plus 7b squared, because 5 times b times 5a becomes 5ab, and b times 7b becomes 7b squared, all over. We can add, they are the same terms. 1b plus 2b, because this is just b. You understand? When you just have b, that's 1b. So b plus 2b becomes 3b. At this very point now, we can see that we don't have exactly the same terms right now. But then you can also factorize in some way. Okay, so let's say we can have 5ab over 3b plus 7b squared over 3b, such that this b will cancel out and you have 5a plus b here 1, b here remains 1b, because so this becomes 7b over 3. And our option for this is 5a plus 7b over 3, that's D. Now another way we would have done this is from this point, you didn't even need to cancel. You just have 5a plus 7b in bracket b all over 3b. All you need to do was just cancel out the b's, and you're left with 5a plus 7b over 3, and you are done. So this and that way you can approach this question. So for the next question, we can multiply this. So multiplying this becomes 2 times 4. So remember to always multiply the coefficient first. 2 times 4 is 8. 8x squared, and then y squared follows, plus 6x squared y squared. Wow. Now we have a complex like terms. They are the same because you have x squared y squared, x squared y squared. So all we just need to do is to add them. Then you have to do 8 plus 6. 8 plus 6 gives you 14. So remember to add your x squared and y squared. Now we cannot add their powers, that is these indices. We cannot add them because they're not multiplying. We can only add them if they are multiplying. So right here we have 14x squared y squared, and option B is our right answer. Okay, question number 5 says x is equal to 3. Solve for 2x squared minus 5x plus 3x. Okay, so let me just write it out. 2x squared minus 5x plus 3, and x is equal to 3. So we are going to substitute 3. So x brackets, 2 brackets, 3 brackets, all squared minus 5 bracket 3 plus 3. So 3 squared is 9. So this becomes 2 bracket 9 minus 5 times 3 is 15 plus 3. 2 times 9 is 18 minus 15 plus 3. Okay, at this point we'll talk about order of operation. So we'll have to subtract before adding from left to right. So subtracting 18 minus 15 is 3. 3 plus 3 gives us 6. And our right option here is C. For the next one, we'll have A is equal to negative 2. So 7A. So let me just substitute directly 7 bracket negative 2 all over A is still negative 2. So negative 2 all squared plus negative 2. So I've substituted every of the values. So 7 times 2 is 14. But we have to add a negative. So negative 14 all over minus 2 squared means minus 2 times minus 2. And that's just 4. Then minus times plus here becomes minus 2. So from here we can have that. Okay, let me just solve here. Minus 14 all over 4 minus 2 is 2. Then 14 divided by 2 is 7 and it's minus. So B is the right option. Okay, so we have x is equal to negative 2, and then for the expression y raised to power 2 over x raised to power 2 plus y over negative 2x. At this very point, know what is value of x, right? So y raised to power 2 all over x is minus 2, so minus 2 squared plus y over negative 2 bracket negative 2. Yeah, so this becomes y squared all over 4 plus y all over 4. So we can actually add them, but that's going to be challenging since we don't have exactly the same terms here. That can be very, very challenging since we do not have the same terms here. So I think at this point we've actually solved this question. So all we need to do is just know that since they have the same denominator, we can as well have something of this nature. Let me put it here. You can have y squared plus y all over 4, and that aligns with option E. This can be a complex one, but I just want you to pay attention to details. So when solving it, it's also necessary you watch your options for you to have more clarity on this. And finally, we have P is equal to 6, or when P equal to 6, 4P brackets P plus R over, so let's substitute directly. 4 brackets P is 6, then again P is 6 plus R all over P is 6R again. So 4 times 6 is 24, right? So we have 24 brackets 6 plus R. 24 bracket 6 plus R, and then 6 times R, this is 6R. For this point, I think we want to distribute. So using this to multiply this, and also using this again to multiply this. So we can decide to distribute or as well cancel out, whatever works fine for us. So let's see how it goes. 24 times 6, that will require us to use a calculator. Okay, I'm using a calculator to save time. 24 times 6 is 144. So 144 plus 24R all over 6R. So 144 divided by 6 is still 24. Okay, and then divided, okay, let me continue from this point. I'm having 6R as my denominator. So let's see, 144 divided by 6R plus, I'm separating them now to see if I will see an option, all over 24 over, this is 24 please, 24R over 6R. Let's see how it goes. So 144 divided by 6 is still going to give me 24 over R plus 24 divided by 6 is 4, right? So 4, then R cancel R, so 24R plus 4. I've seen our answer is E, but I will explain to you how. So for this one, for this 144 divided by 6 is 24, right? So over R, and then 24 divided by 6 is 4. The r we are not cancelled out, so sometimes you need to watch your answer like I say. So let me just explain. Okay, so let me start from here. We'll have 144 divided by 6r plus 24r all over 6r, right? So 6 here is 1, 6 here is 24, so we now have 24 over r plus 6 here is 1, 6 here is 4. We now have 4r over r as well. So since we have the same denominator as r and r, so finally let me just do it here. Finally, you can just simply say 24 plus 4r over r, and that makes sense with this. I hope this is making sense to you. I hope this was very helpful, and we finally come to the end of this lesson. So this is Professional Academic Pod, and this is our Maths Breakthrough series. We're going to be solving a whole lot of questions in this Maths Breakthrough series, and I promise you're going to enjoy your time here. Thank you.